Hello everyone, I welcome you all to the another video in the series of daily Leetcode challenge problem solving. So if you're new to the channel, you can subscribe to the channel. Here I upload in-depth video solutions of Leetcode daily challenges, and you can check out the previous questions. I have added the link in the description box. Or you can also connect with me on my LinkedIn and Facebook. I've added my LinkedIn and Facebook profile in the description box as well. So let us see today's problem. So today the problem is a n queen problem. It is a kind of standard problem. So given a n queen puzzle, so this is an n queen puzzle which we need to solve. Okay. So the problem is that given an n cross n chessboard, right? And we need to place n queens in that n cross n chessboard such that no queens attack each other, right? So let us understand a little bit about the chessboard and how the queen attacks in that chessboard. Okay. First of all, understand that. Let us see. So if we have, let's say, n cross, and let's say I have a 3x3 chessboard. Okay. So let's say this is the chessboard. 3x3 means it has 3 rows and 3 columns, right? It has 3 rows and it has 3 columns. So if I place a queen at some location, at some cell, in the chessboard, then what happens is that this queen at this place will attack all the cells in that row. It will also attack all the cells in its column. It will also attack all the cells which comes in this main diagonal, and it will also attack all the cells which comes in this another, we can say that, the auxiliary diagonal. Okay. So this is how a queen attack. If let's say I have a chessboard, let's say something like this, 4x4 chessboard. So if I have placed a queen here, so let's say I have a queen at this position. So I cannot place any queen at this position, nor this position, nor this position, because this queen will attack on all the cells which falls in this column in which this queen has been placed. I can not also place any queen in this row because this queen will attack in this entire row where it has been placed. Okay. So I cannot place any queen here as well. Okay. This queen will also attack in the main diagonal in which this cell is falling. So this cell is falling in this diagonal, right? So I cannot place anything here, nor here, and nor here. And this queen will also attack in the cells coming in this diagonal, right? So I cannot place anything here and nothing here. Okay. So this is how queen attacks. So let us see now what we need to do. So give us that integer n. So if that integer is n, that means we are solving the problems for n cross n board, and we need to place n queens there on that board, and we need to return all the distinct solution to that n queen puzzle. So we need to put these n queens in such a way that no queen attack each other, right? And whatever the number of distinct solutions, whatever the number of distinct ways in which we can place those n queens in that board, we need to return all of them. And it doesn't matter whatever order you can give. The answer could be in any order. If there are, let's say, only two kind of placement which I can do for the n queens, then order doesn't matter unless you cover all the distinct cases. Okay. So let us understand this as well once. So let us take a very simple example. Let's say I have a 3x3 board, right? This is the board. So now let us say I'm placing the queen at this position. In the first row, I'm placing the queen at this position. Okay. So in the entire row I cannot place this another queen, right? And this is a 3 cross 3 board, right? And we need to place 3 queens, right? One queen has been already done. Now we are left with the 2 queens. So I know that if this queen has been placed in this row, then I cannot place any other queen in this row. Then I'll move to the next row. Then here I'll check, can I place the queen in this cell? No, I cannot, because this queen will attack this cell. So I cannot place. Can I place the queen in this cell? No, I cannot, because this queen will attack this cell, right? Let us check this. Can I place queen on in this cell, right? Because no queen, this queen is attacking all the cells falling in its row, all the cells falling in this column, and all the cells falling in its diagonal, right? So this cell is still not being attacked by this queen. So I can place the next queen in this cell. So I've placed 2 queens. So I'm now left with the 1 queen. So I know since I have placed this queen in this row, I cannot place the queen in the same row again. So I'll move to the next row. So I'll check. Can I place queen in this row? No. This cell is being attacked by this queen, right? Can I place queen in this cell? No, because this queen is attacking this cell, right? Falling in its auxiliary diagonal. Can I place queen in this cell? No. So we cannot place 3 queens in a 3 cross 3 board. Let us do the same for a 4 cross 4 board. So let's say we have this 4 cross 4 board. So we'll start with the similar strategy. So can I place first queen? This is a 4 cross 4 board, and now we need to place 4 queens. So can I place the first queen here? Right. This cell is, because there is no queen, all the cells are free right now. No cell is under attack. So I can easily place this queen here. So now this queen is attacking all these cells, and all these cells, right? Now let us place the next queen. Can I, now I'm left with the 3 queens. So can I place queen in this cell? No, this cell is being attacked by this queen. Can I place here? No. Can I place here? Yes, I can. I'll place it here. Now this queen will attack in this rows, all the cells falling under this row, all the cells falling under its column, all the cells falling under its main diagonal, all the cells falling under this auxiliary diagonal. Okay, so I marked whichever cell which is being attacked by this queen. So let us place another queen. So now I'm left with a 2 queen. Can I place queen here? No. So you can see here all the cells are under attack. So I cannot place any queen in this row. So if I cannot place any queen in that row, that means that I will not be able to place all the queens, because in each row there can, if it is, if each row there is a 1 queen, then only I will be able to place all the n queens. Even a single row is left, then I cannot place all the n queens in this chessboard, right? So for the 4 cross 4 as well, we cannot build a solution. Okay, let us take example for a 8 cross 8 chessboard. I hope you have got it. You can skip this part if you have already understood this. And I am doing so that if there's someone who do not understand it, for them I'm explaining this in depth. Okay, so this is a 8 cross 8 chessboard, and we need to place the 8 queens. So I can place the first queen in this cell. So all these cells are under attack. All these cells are also under attack, right? So to place the next queen, I can play. Now I'm left with the 7 queens. So the next queen can be placed here, right? Okay, so now all these cells are under attack. its main diagonal as well. So auxiliary diagonal as well, right? So let us place the next queen. Now I'm left with the 6 queens. So I will place the next queen at this position. Okay. So when I place this queen at this position, all these cells are under attack. These cells are under attack. These cells are under attack. And these cells are under attack. Right. So this diagonal is up till here only, okay, and till here. So, and one more thing, its main diagonal. So all these cells are under attack by this queen. So the next queen can be placed here in this row. So now I'm left with 5 queens. I can place here. So all these cells will be under attack. If you see any cell which is still neat and clean, that means that cell is not under attack. Like this cell is not under the attack. So I have marked column. I need to mark row as well. It's diagonal and it's auxiliary diagonal. Okay. Let us place the next queen. So in this row, I can place that queen here. So now all these cells are under attack. So I hope you got the gist that how we are placing the queen. Okay. In this way, there will be a final placement where no queen is attacking each other, right? Like this queen is not attacking any of the queen. If I draw this diagram in a neat way, then you will observe what. See. So let us do the placement. First queen in this row is here. In this row, the queen is here. In this row, the queen is at this position. In the next row, the queen is at this position. In the another row, queen is here. Okay, so on. So you can see this queen is not attacking any of the queen, right? Because you can see that it is attacking in this row, so no queen is here. This is attacking in this column, no queen is here. It is attacking in this diagonal, no queen is here. This queen is also not attacking any other queen because no queen is in this row, no queen is in this column, no queen is in this auxiliary diagonal, and no queen is in this male diagonal. Similarly, this queen is not attacking any other queen. No queen is placed in this row, no queen is placed in this column, no queen is placed in this diagonal, and neither this diagonal, right? So in this way, the final placement has to be done. There could be other ways as well in placing the queens. Let's say here I had choice. I could have placed the queen here as well and then made a different arrangement. So all the different arrangements which can be done in such a way that no queen is attacking the other queen. All such arrangements we need to return. Okay. So let us understand the further part of the problem. Okay, so we can return in any order. Then it is saying that the solution contains distinct board configuration of n queen placement where q and the dash this dot both indicate a queen and an empty space. So the solution means in the solution I need to return the placement, and in the placement since I need to return all the board configurations, right? So list of board configuration. Okay, so there will be, let's say there are k number of different configurations. So I will have a list of size k. Okay, the size of the list will be k, and each configuration tells a placement in the board such that no queen is attacking the other queen. This another list gives us a different pattern in which we can place those n queens such that no queens attack the other queen. So there will be k number of distinct placement which I can make, and each placement is a board which gives the manner in which I have placed the queen, right? So if you look at the solution here, the see that if the board is 4 cross 4, then there the size of this list is 2. That means there could be two different configurations to place the 4 queens. In the first configuration I can place the queens in this way, right? So how it is, this is the first, you can see that this is the first configuration, this is the first style in which I can place those queens. So each item will correspond to a row. This is corresponding to the first row. First row means, and if you read this, this is dot q means the first cell, zeroth column in the this first row is empty. Then the next column there is a queen. Then in the next column again it is empty. Then again it is empty. Then this is the second row. So you can relate this thing here. So this belongs to this row. First of all, it is if I show you this configuration, this entire configuration, this list correspond to this one, and this list correspond to this configuration. Okay. Then if I see this list for this board configuration, this first string in that list correspond to the first row. The second string corresponds to the second row. This third string correspond to the third row, and the fourth string correspond to the fourth row. Okay, so this means dot q means first is empty, then queen, then empty, then dot q, empty, queen. In this way, we can do. Similarly, you can read this thing. So we need to do something like this. So let us see how we can approach the solution. And the constraints are, let us also read the constraints. So n can go up to 9 only, 1 to 9. Okay. So let us see how can we solve this problem. So one of the way could be, if I have this board, let's say I had this 4 cross 4 board itself. So what I will do, I'll explore the choice. First of all, I'll check, can I place the queen at this position? If I get a green flag, I'll place the queen. And then I'll find, can I, at what position I can place the queen? It says that I can place here as well, green flag for, sorry, I cannot place here, I cannot place here, I can place here. It gives me a green signal. And I can also place here as well. So first of all, I will place the queen here and explore the other path. Then if I have placed the queen here, then I'll check in the next row, where can I place the next queen? I cannot place here, cannot place here, cannot place here as well, and cannot place here. So since there are n rows and there will be at least, we need to fill, it is mandatory condition that each row should have one queen. Otherwise, we won't be able to fill all the n queens, right? Why? Because our single row cannot have two queens, because if there is a single queen, that queen will attack the entire row. We cannot place the queen, two queens in the first row, in a single row, right? So it is mandatory to place the queen in the, there will be only a single queen in each row. And if we miss onto some row, if we cannot place any queen in some row, that means that queen will never be placed and the board will never be filled by the n queens. So we will not go further. We'll come back here. We said that we had made a wrong choice. Instead of placing the queen here, just place the queen here. Then I'll explore the other choices. Can I place the next queen here? No. Can I place here? Yes. This is a green flag. So I'll place here. Then go place the next queen. So can I place here? No. Can I here? No. Not here. Not here as well. This cell is under attack. This cell is attacked by this queen. This cell is under attack by this queen. this again under by this, and this cell is again under attack by this queen. Then I'll come back here. I'll say this was a wrong choice. Don't place the queen here. Can I place here? No, this is under attack by this queen. And I can also cannot place here as well. So I'll go back because there is no other choice left here. I've already explored whatever the choice I had, and there are no columns after this. So I'll go back. I'll say, so I'll say explore the other choice. Then it had already covered all these choices and it is in the last column and there are no choices after this. So it will again empty the queen and go to this place. It will say explore the other choice. So this cell will be emptied and the queen will be placed in the next cell, next choice. So this is the empty cell. We'll place the queen here. Okay. So now if you see this, this is the current state of the board. This is the current state. So I have placed the queen here. Then I'll fill the next row. Can I place here? No. Can I place here? No. Can I place here? No. Can I place here? Yes. This cell is not the under the attack. So move to the next row. Can I place here? Yes, I can. So place the queen here. Okay, move to the next row. Can I place here? No. Can I place here? No. Can I place here? Yes, definitely I can. This cell is not under the attack. So I've already placed the end queens. So if you see, I've figured out the first configuration of the board. First queen is here, second queen is here, third queen is here, fourth queen is here. And see, this is exactly the same. Second, fourth, first, third. Second, fourth, first, third. Okay. So I have already built the solution. Then I'll say that I've placed this queen. Then again I'll say that okay, go to the next row. When I'll come here, I'll say that I've already crossed the last row. That means I've already placed the end queens. If I've already crossed the last row, that means it is a solution. The current state of the board is one of the solution. Then I'll place this solution in my original list. So this configuration will be placed in this list, and this is the configuration of this cell. Okay. Then I'll go back here. I'll come here. I'll say, okay, explore the other choice. Okay, this is something like backtracking. We are backtracking. We have done the job, and then we are going back again. So I'll come here. I'll say that, okay, just leave this cell, explore the other choice. Can I place here? No, I cannot. This is under attack. Explore the other choice. There is no choice again. So go back, backtrack, and explore the other choice, whatever you have made at this state. So at last time I made the choice by choosing this cell. So I'll empty this cell. I'll explore the other choice. Can I place here? No, this is under attack. Can I place here? No. Can I place here? No. So I have no further choice. I'll go back and come here and I'll say that to this row, explore the other choice. Since it is already in the last column, so there is no other choice. So it will also empty this cell and backtrack. It will say to its previous row that explore the other choices. Okay. So again, the next choice will be this cell because this is already this has already been explored. This has been explored. So the next choice is this cell, and this is not under the attack. So we'll choose this cell this time. So this cell will be chosen and it will say now go to the next row and explore the choices. So can I place here? Yes, I can. Okay. It will say explore the choices in next row. Come here. Can I place here? No. Can I place here? No. Can I place here? No. Can I place here? Yes. Because this is under attack by this cell. This is under attack by this. And this is also under attack by this. But this cell is not under the attack. So it will place here and say that explore the next choice in the next row. So come here. Can I place the queen here? No. Can I place here? Yes, I can. So I'll place here the queen because this cell is not under the attack by any of the queen. Then it will say go to the next row and explore the choice. When I came here, I saw that I've already crossed the last row. That means this is also one of the solution because all queens have already been placed. That's why I have crossed the row and building the solution, which is not the row of the chessboard. Okay, so this is another solution. So I'll put this state of the board in my answer list, right? So you can see the second solution. This is a third, first, 3, 1, 4, 2. So third, 3, 1, 4, 2. This is another solution. Then I build a solution. and it will again come here, backtrack. It will say this cell, explore the other choices. So it will empty this cell. It will say, can I place here? No. Under attack by this cell. Can I place here? No, I cannot. So there is no choices left. It will backtrack to this row. So now this cell, this row will explore the other choices. So I'm already at the last cell. There are no choices left. So this will empty the cell and backtrack and say that you explore the other choices. So it will say that, okay, I'll empty this cell. So can I place the queen here? No, under attack. Can I place here? No. Can I place here? No. So it will backtrack to this cell. It will say you explore the other choices. There is no choices left. Whatever the choices were, we have already explored. Now we do not have any choice. Now you pick the next choice. So now it will pick the next choice and the queen will be placed here. And then the same thing will happen, right? So in this way, we can do this, right? It is a kind of DFS traversal. Okay, if this zeroth row, first row, second row, third row, zeroth row, first row, second row, third row. So initially, I'll say that, can I place the queen at 0, 0? Yes, I was able to. Then solve for the next row. Okay, if I was at 0th row, I was able to place the queen, solve, then on the first row, go check for the first row 0th column. Can I place here? If I had placed here, can I place here? No. Then explore the other choices. Can I place at 1, 1? No. Can I place at 1, 2? Yes, I can. Now, if I can, then go explore the choice in the next row. So this will go to the next row, which is 2. It will explore the first column, 2, 0. Can I place here? No, I cannot. So it will backtrack to this position and then it will make call to the next choice. This will be 2, 1. So can I place the queen here? No, I cannot. It will again backtrack to this position, explore the other choice. Can I place queen at 2, 2? So can I place the queen here? No, again, this is under attack. Let me make it little clear. Okay. So can I place queen at 2, 2? No, I cannot. It will backtrack. It will explore the last choice, which is 2, 3. Can I place queen here? No, again, I cannot. I came here and I saw that the next call will be 2, 4. But since fourth column is not there, that means I've explored all the choices here. That means this queen has, when this was placed at this position, we had explored all the choices in the next row and we have came back. It did not work. Then it will backtrack to this position at 0, 0. And first of all, we came here, we say that if I had placed the queen at 1, 2, I wasn't able to place any queen here. So it will come back, okay, come back here, and then it will explore the next choice. Okay, it will backtrack here, then it will call at 1, 3. Can I place at 1, 3? Okay, can I place at 1, 3? Yes, I can. So 1, 3 will again explore choices in the next row. First of all, it will call in the second row, 0th column. Can I place here? No, I cannot. It will backtrack. Can I place at 2, 1? Yes, I can. So it will again explore the choices. Okay, in this way, the call is going to happen. So this is a kind of DFS traversal, right? We are going in depth. If I am placing here, then go to the next column and explore the choice. If I was able to place here with this choice, go to the next row and explore the choice. If I was able to put the queen here, go to the next row and explore the choices. And once I'm done, I'll come back here, explore the next choice, and then again deep diving into that. So this is a depth first traversal. I'm going in the depth. Once this is done, then I'll again come here, backtrack to this position, and then this will again explore the choices in the next columns, right? So this is a DFS traversal. This is what happening. So let us code the solution. So what I need to do, let us understand how should we code this solution. So I've been given this n. So first of all, the answer should be a list of string. So I'll create a list of string which, let's say I'll say this is the boards. This will store all the different solutions, all the different configurations of the board, right? Then let me create a 2D array of board of size n cross n. So I'll create a 2D array of characters. I'll name it as board, and the size of the board is n cross n. And let us also fill this board. Initially the board is empty. So if the board was empty, I'll put all the board of I comma j is equals to what? Dot, right? Okay, fine. So I've created this board, and now I'll call my DFS function. Let's say there is a DFS function which explore all these choices. So I will call this function, and what should I pass to this function? First of all, the current configuration of the board and boards in which all the valid answers has to be added. Okay, and anything else? So I don't think there should be anything else. If there will be, we'll add another. So I assume that this DFS will build my solution, and then I'll return boards, right? So let us write this function, DFS function. So this is void because I'm not returning anything by this function. It accepts a character array, which I say board, and it also accepts what, this list of string boards. Okay, and let us also pass one thing, from which row I'm building the solution. So initially I need to place the queen in the first row, 0th row, right? So I will be starting from the 0th row, right? So here I write int row, at what row I am starting with. So since I've told you, if I'm starting, if at some position, okay, let us handle the edge case separately. First of all, what should we do? We'll check for a particular row. I will check each cell if I can place the queen at this cell or not. If I am able to place, I'll call the DFS function for the next row, right? So I'll check. I'll do what? For in I equals to 0 and I is less than what? So let us give it a better name, because generally we refer column with J. So because in this current row, I'll explore all these cells. So I'll explore all the columns in this current row. So that's why I'm doing for J equals to 0 to J is less than what? Board dot length, right? Board dot length will give me the value of n, which is a square matrix. So it will give the number of rows, and which is exactly equal to the number of columns, right? Board dot length, and it will be J plus plus. And if it happens that at the current row and jth column, if this cell is not under the attack, so when this cell will be under the attack, I need to first of all check if there is any queen. See, in general, if let's say I was at this cell, I need to place, I am checking whether I can place queen at this cell or not. So what I will check, if there is a queen in this entire row or not, right? There's definitely no queen in this row. I need to check whether there is any queen in this column, right? Because there will be no queen in each row. Because what I'm doing, if I'm able to place a queen in a particular row, then I make call to the next row. I do not place the next queen in this row itself. Okay, so there will be never be two queens in a single row. So I do not need to check the row. What I need to check, if there is a queen in this column in which I'm placing this queen, right? So let's say there is a function check column. Check column, what column? Jth column. Check the jth column. jth column, right? Check this jth column in this board, right? If this is fine, this will return a boolean value. If it returns true, that means there is no queen in this cell. Now also check this main diagonal, right? Check this main diagonal. So if it is true, then I'll also check main diagonal check, main diagonal check. So I'm at this position. This is the received row and the jth column, because diagonal is always identified with I comma j, right? If one of them is changed, then the diagonal will be changed. If j is changed, if I came here, then the diagonal will be this. If I came here, then the diagonal will be this one. If I change the I value, if I come here in this row, the diagonal will be this one. If I increase the I value, I'll come here and the diagonal will be this one, right? So this cell, what the diagonal is, will be characterized by both these variables, at what row I am and at what column I am, right? So I'll pass both these value, row and the column and the board, right? So this board is basically to save the configuration, current configuration of the chessboard. And if this also returns true, that means there is no queen in this entire row. That means this cell is not under the attack by the queen in the main diagonal. Then I need to check this auxiliary diagonal as well, right? So if this is also true, then aux diagonal check, right? So again, this will be characterized by both variables, row and column, and we'll pass the board as well. If all these are true, that means there is no queen in this diagonal, nor in this diagonal, nor in this. So I can place the queen and explore the choice for the next row, right? Then what I will do, I'll put, first of all, I'll put the queen at this position. So I'll change the current state of the board. I'm at row, this row, I'm at this row and jth column. And here I found that this cell is not under the attack. So I'll place the queen at this position and explore the choice for the next row. So now I'll pass the row plus 1, which means explore the choice for the next row, pass the current board configuration and the final answer, final list, right? And this will build the solution further. Now, when the call will come back here, backtrack here, then that means while placing the board here, I've explored all the choices here. So I need to explore the choices in this cell. So since I had already explored the choices up till here, I need to move forward, right? So to explore the choice, first of all, I need to again make this cell empty. So I will do board of rowth row and jth column again equals to what? Dot, right? And then it will be j plus plus, and then it will check for the next column if it is free or not, right? In this way, this will build the solution. And while doing row plus one, there will be a time when I will cross this last row. That means I have placed all the queens. So whenever I enter this DFS function, I'll check if this row is board dot length. That means I've already crossed the last row. So this is the current board contains one of the configuration in which no queen is under the attack. So what I will do, this is the current answer. I need to add this state of the board in this final boards, right? So how I will add? So first of all, I'll create, because a list of string has to be added. So I'll create a list of string. Let's say answer is equal to new. So I have created this list, and then for the each row, there will be a separate string, right? So I'll iterate over the each row here. So for let's say I equals to 0 and I is less than row dot length I plus plus, and to this I will add, first of all, I'll add this string. So this is the first row. So answer dot add Answer dot add what? I'll create the string from the first row of this board. Board of I. Board of I means what? This row. So if I pass this array to this function, so this will create a string of this entire row, right? It is a character. This is a character array which I have created board. So what it will do? It will this function will create a string by concatenating all these characters, right? So for the first row, I'll get this one, right? And I'll adding this to this answer. This is my answer array list, right? And again for the next row I'll be adding this, and then for the each row I'll add this string. And finally, when I have added all the strings, that means answer is ready. That means I'll add this answer. I'll add this answer to my boards variable, and right, and I'll return that, right? So this will work. So now we need to write these functions separately. So I'm checking the column, right? So let us write this function as well. This is a check column, and the check column will be, I'm at this call column, let's say this cth column, and I'm also receiving this board configuration, this board, right? And how I will be checking if I am placing, a queen here, that means starting from the 0th row till the last row, I need to check if all the cells are free. Even if I encounter any of the cell contains queen, that at that point itself I'll return false. I cannot place the queen here. So I'll start from here for int, let's say row equals to 0, and row is this, then board dot length I plus plus. And since when I will be checking this cell was already empty. So if the board of this row and cth column contains what? Q, that means at that cell queen is already there. So at that instant only I'll return false, right? But after iterating over all the rows, none of the row had Q in that cth column. That means all the columns, all the columns, all the row in this column do not contains Q. That means no queen is attacking this cell. No queen in this column is attacking this cell, right? So here I'll return 2, right? Then column is checked. Now we need to check. We need to write this function, main diagonal check. Let us do renaming in a better way. So main diagonal check, it receives a row, it receives a column, and it receives this board as well. Right? So what I will be doing, if in order to check the main diagonal, I will go, if I'm at here I comma j, so first of all check something in this direction. In this direction, how I will be coming? I'll decrease the row and decrease the column, so I'll be here. Then at this position again I'll decrease the row by 1, so I'll come at this row and decrease the column also by 1, so I'll come here. So in this way I can trace this part of this main diagonal, and this part will be traced by what? First of all, I'll increase the row count I plus 1, and then to that I'll also increase the column j plus 1. So I'll be here and check here and so on. So in this way I can do. And where I need to stop, when I will be tracing this, I need to stop. What will happen is that when I encounter the last column, let's say if I am here, till what position I need to check? At this position, because before then after this, before this there is no column. That means I need to stop here. When I'm here, I'll be stopping here. So that means till j is greater than, till the column is greater than equals to 0, I have to explore the diagonal. The moment I have explored a negative diagonal, negative column, that means I have already reached to the end of this main diagonal. And similarly here, I'll come to what? The last column. If I come to the last column, that means I have traced the all the cells in this diagonal. Let's say if I was here, I would have stopped here because this is the last column. If I was here, I would have stopped at this position, right? So what I will be doing, let's say I create a variable int I equals to row and j equals to column. And what I will be doing, initially I'll go in this direction. So in this direction till j is greater than is equals to 0. Till j is greater than equals to 0. Till j is greater than equals to 0. And what I will do, if this board of I comma j is equals to queen, if this contains queen, that return false because that queen will be attacking the current cell. If that is not the case, I'll decrease I, I'll also decrease j, right? And this will go till the j is greater than 0. Once the j becomes negative, it will come out. Now I need to trace this part of this diagonal. So let us again initialize. Since I will again initialize ij to this position and then move to this direction. So I equals to row, j is equals to column, and while j is less than board dot length. While this is true, if board of I comma j is equals to q, return false, right? And do what? Do I plus plus and j plus plus, right? And if none of the cell encountered q, that means this will be the loop will be over and I'll come here and finally I'll return true. That means none of the cell in this main diagonal contains queen. Then I need to check the auxiliary diagonal, right? So let us do auxiliary diagonal check. It again receive row, column, and board. So how the auxiliary diagonal is working? Let us see this. So this will be the auxiliary diagonal for this cell. Okay. So if this position is I comma j, this is what? This is row minus 1, I minus 1, and j plus 1, right? And if I was here, this is what? I plus 1 and j minus 1. In this way, this is happening. If I want to explore in this direction, then I have to do this. And if I want to explore in this direction, I have to do this. And when I need to stop, when I need to stop, see here, at this cell, I'm at the last column, right? I'm at the last column. So I cannot go, I'm doing j plus 1. I cannot go after the last column. So if j becomes the last column, I need to stop. And here as well, this I'm doing j minus 1 and I plus 1. So it might happen that I might cross the last row here. See, this is the last row. So I need to stop at this position. Right? You can do also one thing, rather doing this, we can check two conditions. See here, since I'm doing I minus minus, j minus minus, here doing I, j is greater than 0, I should also write I also greater than equals to 0. Okay, at some moment, any of them become negative and we cannot access the negative index. And like this, I'm doing I plus plus, j plus plus, at some point of time, it will cross the board size, either the last row, either the last column. So I can check both these things. So in this function, we do not require this, but here we might require that. So I'm also writing this thing here as well. So I should be less than board dot length and j should also less than this. So now for auxiliary diagonal, what I was doing to explore this path, I minus 1, j plus 1, I minus minus, but j plus plus. Since I'm doing I minus minus, so I should be greater than equals to 0. And I'm doing j plus plus, so j should be less than equals to board dot length. Any of the condition violates, then I'll come out of the loop. That means I've traced all the cells in that direction. Again, I'll start here. I'm doing I plus plus, and what I'm if in this direction I will do I plus plus and j minus minus, right? J minus minus. So if I'm doing I plus plus, so I should be less than equals to board dot line, because at some point of time it will cross the board line, and doing j minus minus, it should be j greater than equals to 0, right? And if I do not find any of the abnormality, I'll return true here. And if all the conditions are true, I'll put the queen at that position and I'll call the DFS function. So let us check if this is working. Cannot convert it. Okay, by mistake, I've made here. Cannot find the symbol. It should be answer. Oh, sorry, it should be add. Add answer. Okay, cannot find the symbol. Which symbol? I plus plus. Okay, line 43. So it should be row plus plus. I hope there is no other error. Okay, again I'm at line 33. What is happening? Check column. I'm passing row. Okay, what is this? I should not pass I. It is rather J. Right, current row and J is the column. Okay, it is working fine. Let us run for all the test cases. 1, 2, 3, 4 is already 5, 6, 7, 8, 9. Let us check. So we need also do analysis. Okay, so it will be accepted because we have already checked on all the test cases. So let us submit this. So it is getting submitted. Fine. So let us analyze what is the time complexity for this. So let us say the board size is 9 cross 9, right? We need to place n queen. So in the first row, I have 9 choices to put the queen, right? Now in the next row, you'll say again there are 9 cells. So we might have 9 choices to put the cells, put the queen, but we cannot put queen in the. If you see, if you do not understand very deeply, if you simply say that here are also 9 choices, then all these rows have 9 choices. So total choices will be 9 raised to the power 9. And what is this 9 raised to the power 9? We can check this. The 9 raised to the power 9 is this. So it is somewhere around 3 into 1, 2, 3, 4, 5, 6, 7, 8. 3 raised to the power 8. So this is a huge number. This might not get accepted, right? So this will not be accepted. But if you observe carefully, there is a catch. We are not exploring all the 9 to the power 9 options. What we are doing, if I have placed a queen at particular position, this choice has already been, there is no choice to place queen here, and further I will not be exploring other choices, already reduced. This cell is also reduced, right? So here I have only what, 2 choices have been exhausted. So I have what number of choices? Only 7 choices left. So in the first row I had 9 choices, in the next row I have only 7 choices. Again this will further reduce, and this number will constantly will reduce. And even if you consider upper bound of this will be 9 factorial, 9 into 8, right? So what will the value of this if I do something like this? If I calculate factorial of 9, okay, I think the Python do not have something like, so let us manually calculate this. 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So it is a very small number, even if we are considering upper bound of this, right? This was 7, but I have considered it as 8. This number will further reduce. This will further reduce. And even 9 factorial is this 3 1, 2, 3, 4, 5, 3 into 10 to the power 5. This number will be even smaller, this original. So I'm not, I will be somewhere exploring 10 to the 4 options only. So that's why checking if I can place queen at this cell will prune out other the invalid options. I should not do something like this. I'll place a queen here, place a queen here, and then finally check if this is a perfect position. Then I'll come here, then I'll make other configuration. I'll put here and put queen here, and then like this, then check if this is a perfect position. No. So in this way, if you do something like this, you'll explore all the 9 to the power 9 choices. But before putting, I'm checking the conditions. So that actually avoids, that actually restricts me to explore all the paths. If I place simply here, I will exploring all the other paths for the all the remaining rows. And initially, if I check that I cannot place here, so all that thing, this computation will not be done. So we have done massive pruning here. So that's why the solution is getting accepted. Okay. So I hope you understood the concept. If still there are doubts, you can write them in the comments. I'll try to answer those. And I hope you liked the video, enjoyed the video, you understood the concepts. See you in the next video.